we are discussing a chemistry lecture here. In this lecture, we are focusing on a concept of solubility first. Now, in this case, when I am discussing, we are discussing at different level. So first, you should be aware about molecule nature of water, and for that purpose my request is that you should not observe this lecture without observing prior chemistry lectures. Important lectures are there. They are atomic structure, then chemical bonding. So if you are having thorough knowledge of atomic structure, whatever discussed in our lecture, and molecule, that chemical bonding chapter, then you will able to understand these concepts more clearly. So first thing, we are discussing about water molecule nature, because when we are discussing various facts about solubility, majority time we are using solvent as water, sometime alcohol, benzene. Now you are aware the water molecule structure. This is H-OH bonding. Here you are aware, now there is bond angle, because lone pair of electrons are also there. Two lone pairs of electrons are there, and therefore this bond angle is 104 degree and 28 minute, or simply I may say 104.5, close to that. So this is water molecule, single water molecule. But see, there is a concept. We are discussing that concept in periodic table in detail, but right now I want to give you certain idea. That is called as electronegativity. Now this is the tendency. Say, I am not using word as energy or something like that. This is the tendency of an atom to attract electron cloud in bonding condition. I am revising. What is electronegativity? It is tendency of an atom to attract electron cloud in bonding condition. That is called as electronegativity. Now every element is having electronegativity. For example, hydrogen. Hydrogen is having tendency to acquire electron in bonding condition from oxygen. Oxygen is having tendency to acquire electron from hydrogen. So like that, every element is having this type of tendency. Now in case of water molecule, the oxygen atom is having more tendency to acquire electron from hydrogen. So I may say here, electronegativity of oxygen is greater than hydrogen, and therefore oxygen will try to pull out electron cloud from hydrogen. This representation is wrong, but I am explaining just that oxygen will try to pull out electron cloud from hydrogen. Same way here also, both hydrogens are having as same element, same electronegativity. So oxygen will try to pull out hydrogen cloud from both. As a result, electron will spend less time over here and more time over here. As a result, this will acquire very small positive charge. We are denoting that as delta plus. Same way, this will also have small positive charge. We are denoting as delta plus. Keep in mind, this letter in Greek is pronounced as delta. This is small delta, whereas when I am saying this is capital delta in Greek language. That's why you are aware in geography we are using word delta land. So that is triangle shape land, but that delta is capital, whereas this delta is small. So this is delta plus and delta plus. Whereas oxygen will acquire negative charge, so it is indicated as delta minus. Don't tell me delta plus plus delta plus that it should be 2 delta minus. No. Why? Reason is there. Delta is here used as indefinite numerical adjective. I am using word indefinite numerical adjective. What is adjective? You are aware. Numerical adjective, the adjective which is showing number. Whereas indefinite and definite, suppose I am saying 5. 6, 7, there is a definite number. So these all are definite numerical adjective. Whereas delta, say forget delta, many, more, like that words are there. We are not able to get. Many means what is the exact number. I can say there are many mangoes and there are many oranges. So there are 2 plus many, no, or twice into many mangoes and oranges, no, we are not able to do that. Similarly, delta means small, but what is the exact amount we are not predicting out, and therefore don't write here 2 delta. Instead of that we should consider delta only. So this is delta plus and this is delta minus. Suppose I want to draw structure of molecule, it should look something like this. This is oxygen atom. I am not writing O. This is sphere, oxygen atom. Whereas hydrogen atoms are here in bonding condition. Hydrogen atoms are here smaller than oxygen. There is overlap between orbital. You are aware that oxygen atom and this is hydrogen atom, there is overlap, and molecule should look something like this. Whereas as it is overlap, this portion is not shown. Whatever observe, that is shown here. Something like Mickey Mouse, you can observe structure. Whereas bond angle is measured from this way. The center, this is 104.5 or 104 degree 28 minutes. So this way you are getting water molecule. Now I am forgetting the bond angle here. Instead of that we are trying to make the look of water molecule. This will be something like this, where we are getting here delta positive charge, delta positive charge and delta negative charge. Getting idea of structure? This is structure of water molecule. Single. But as there are many water molecules, there is obvious thing that there is attraction between this oxygen. Now this oxygen is having, suppose I am showing, there are no colors, I am just showing you this way. This is having positive charge, this is having negative charge. So secondary force get developed over here, and there is attraction between delta positive charge of this hydrogen and delta negative charge of this oxygen. A weak connection, I am not saying this is strong, this is very weak, but still some connection is developed over here. This is because oxygen molecule is comparatively smaller in size. Oxygen atom is comparatively smaller in size, and therefore it is having very high charge density. Charge density, very easy to understand. When we are using word density, I am using density as density equal to mass upon volume. If I want to explain charge density, then charge density equal to charge upon volume. So charge upon volume, that will give me charge density. Now here oxygen is having smaller volume and charge is there, so we are saying it is having high charge density, and therefore it can form this type of bonding. This type of bonding is called as hydrogen bonding. I am using word again. This type of bonding is called as hydrogen bonding, where orbitals are not involved directly, but there is weak attraction developed between molecules. As a result, this type of forces, now you can imagine same way here with another water molecule, here with another water molecule. So like that, this is having tetrahedron shape. You are aware of shape tetrahedron. So on that tetrahedron shape, this type of structures are developed and weak bonds are formed. They are called as hydrogen bond, or this concept is called as hydrogen bonding. This way we are getting here hydrogen bonding. Now here it's very clear for you that there is formation of hydrogen bond. What is the evidence of this hydrogen bond formation? Supposed to be a similar molecule is there. This is water. So similar molecule is there, H2S, hydrogen sulfide. Oxygen and sulfur are having many similar chemical properties. But sulfur molecule is bulky. Oxygen is having mass as 16, whereas sulfur is having mass as 32. As mass increases, boiling point increases. So theoretically, water should have less boiling point than H2S. But practically, H2O, that is water, is having more boiling point than H2S. This is because sulfur is bigger molecule, bigger atom than oxygen. As atomic volume is more, denominator will be more, charge density will be less. As a result, the molecule is not able to form hydrogen bonding. And as hydrogen bonding is absent, we are getting less boiling point. If hydrogen bonding is there, in order to boil, this bond should rupture first. Now let us think, what is the boiling process? Or rather, I should go for heating. Okay, let us check out. So there are atoms. They are regularly arranged in solid state. Now, why these gaps are there? I should show all atoms sticking together, but no. Every atom is vibrating in all possible direction. I am showing here few directions. But every atom is in continuous vibration in all possible direction. Maybe like this also. I am not able to show this, but this way. So every atom here is continuously vibrating. Try to recollect, we discuss about dark matter. What is dark matter? Dark matter is not emitting any type of radiation. But why radiations are emitted? This is because the vibration motion of atom. At minus 273.15 degrees Celsius, that absolute zero temperature, this vibratory motion stops. And therefore matter is not at all emitting out any radiation. But as temperature rises, these atoms or molecules start vibrating and we are getting different types of radiations. Now these atoms are in continuous vibration. As temperature increases, their amplitude increases. What word I am using here? Amplitude. Now you are familiar from physics lecture, what is amplitude? So this is the increase in amplitude of atom or molecule. Okay, let us make simple arrangement. Again and again I should say atom or molecule. Instead of that, I should use word only molecule. Because in modern days, we are classifying this molecule as monoatomic molecule, diatomic molecule, triatomic molecule and so on. So here I should consider only molecule. You can consider molecule maybe monoatomic. What is mono? Single atom, like sodium atom, helium atom, monoatomic. Diatomic, hydrogen H2, oxygen O2, chlorine Cl2, triatomic O3, tetraatomic and so on. So like that various molecules are there. I am now using word as molecule. These molecules are in continuous vibration. As temperature increases, its amplitude increases. That is maximum displacement from mean position. Say for example, initially they will vibrate till here, but as temperature increases, it will vibrate till here. Again I am increasing temperature, it will vibrate till here. So like that, gaps between molecules start increasing. Now these molecules are having strong attraction between each other. This is the attractive force that is present in molecule. We are simply calling this as weak van der Waals force. I am using word weak van der Waals force. So because of this van der Waals forces, these molecules are trying to attract each other. Not only this molecule, even this, they will try to attract each other. But as temperature rises, amplitude increases, and then as distance increases, force decreases. This distance and force, they are inversely proportional to each other. And so we are getting rising distance, decreasing force. If I am heating out, this is solid state structure. If I am heating out to very great extent, what will happen? The amplitude will increase. As a result, I am getting more short wave radiation. I am not saying short wave, more shorter wave radiation may be possible, that is in visible range also. You may observe iron piece, heat out. You will feel it is warm, then it is hot. But you will not able to observe any color for that. Again heat strongly, you will get it is converted into red color. It start emit out light in red color. That means now it is entering in visible range. So like that, their amplitude increases, the radiation's frequency also increases. But at a certain point, the distance increases to such a great extent that the attraction force breaks down completely. And as a result, this entire structure gets collapsed out. We are saying this is the melting process. This is melting point of substance. So surprisingly, we will get entire structure get collapsed out and we are getting liquid. Now this motion is vibratory motion. In case of molecule, now I am removing this structure, I am showing some different structure here. Like this is a container. Now it is filled with many molecules here. Now they are having freedom to move here and there. Say in solid state, molecules were vibrating. Vibrating means what? Suppose this is mean position. This will move like this. So again and again following same oscillation. Maybe in this direction, maybe in this direction. But in all possible direction, this atom or molecule will move, vibrate. But here there is no like vibration. It can move from here to here, here to here, anyway. In any direction it can move. This is translatory motion. So this is changing its position, and it is not necessary recurringly this should come at this position only. It may come, may not come. So this way molecules are transferred, they are having wandering motion here and there. But there is some sort of attraction force between these molecules, and therefore they are maintaining their level. This is volume maintenance. I am increasing out temperature. What will happen? The volume will expand slightly. Why? Because the velocity of molecule will increase. You are aware kinetic energy of molecule. I can give here half mv square. You are aware V stands for velocity, m stands for mass. Now mass of molecule will remain same. So if I am supplying energy, the kinetic energy of molecule will increase. What will increase? Only V and not m. So molecule will initially move like this, but on heating it can move like this. Getting idea? So on heating molecules start moving with greater speed, and as a result its area of occupants increase, and ultimately we are getting slight rise in volume. So as temperature increases, volume also increases. Intermolecular gap increases because it is getting more and more time, more and more volume to get move. You can check out if liquid is there on heating, it will expand. Want to observe? Just observe what is thermometer. If mercury is used in thermometer, or sometime alcohol is used as thermometer. Alcohol is also liquid at room temperature. Mercury is also liquid at room temperature. In India, we are considering room temperature as 25 degrees Celsius. Now, at that time, you can observe just by rising little bit temperature, the mercury level increases, and by decreasing temperature, mercury level decreases. What is that? That is the rise in volume of mercury or fall in volume of mercury. So, this is because of heat temperature, high temperature or low temperature, the gaps are there. Getting idea? Now, in liquid state also, hydrogen bonding is present in water, and therefore the molecules are not able to move in the surrounding. Yeah, it is there that to some extent they are moving, but right now this is not our part right now. So I am not discussing. We'll discuss that in some different example when we are discussing certain physical chemistry topic like boiling point and melting point. Here I want to explain solubility, and for that purpose whatever relevant part is there, that I am explaining. Now the moment we are able to understand liquid state here. Now we are not going to gaseous state right now. I am just explaining what is liquid state. I am stopping over this and we are focusing on solubility. Now this is water, pure water. Imagine, let us take, this is having temperature 20 degrees Celsius. The volume of water is 1 decimeter cube. In general discussion we can consider 1 decimeter cube as 1 liter. I am saying general discussion 1 decimeter cube as 1 liter, and 1 liter is volume occupied by 1 kilogram water at 4 degrees Celsius. I am revising, 1 liter is not SI unit, but still it is widely used. 1 liter is volume occupied by 1 kilogram water, pure water obviously, at 4 degrees Celsius temperature. Now here I am considering this 1 decimeter cube water, 20 degrees Celsius temperature is there. I am adding out common salt in this. Little bit, pinch of common salt is added and stirred out. On stirring, this salt will disappear in the water. Now where does exactly salt goes? We are saying it is dissolving in water. Is there rise in level of water? If you check out, it is not that extent. Ideally it should not. Theoretically little bit should be there, but no, because we are adding out just little bit of salt. Then thing is that where that salt goes? Answer is intermolecular space. In that intermolecular space, salt molecule get accommodated. Getting idea? Now I am not going in detail, dissociation etc. Just I am explaining here concept of solubility first. Add little bit salt more, stir it, it will dissolve. Add still little bit salt, it will dissolve. Like that, go on addition of salt slowly and steadily. You will get that salt is dissolving continuously. Then a stage will reach that no more salt will dissolve. Add on salt, that salt will just accumulated at bottom. It will not move here and there, but it will be there. Stir it, it will move, and again it will settle out at bottom. This means now no more salt is dissolved in this water. I can say now water is saturated. What word I am using here? Water is saturated with respect to common salt at particular temperature. What is that particular temperature here? 20 degrees Celsius. So this way we can dissolve salt till a definite extent. Beyond that it is not possible. Now still I want to dissolve whatever remaining salt here. Let us check. Now first thing, why water becomes saturated with salt? The reason is that all intermolecular gaps are filled out, and so no more salt can accommodated over there. Now sorry, I have to heat this water. I have to rise temperature. The moment I am rising out temperature, say for example the temperature is okay. Now this is not perfect data. I am giving you example. At 20 degrees Celsius, suppose 100 grams salt is dissolved. At 30 degrees Celsius, you may add still more salt. It will continue to dissolve in water. So as temperature rises, the solubility increases. More and more salt will dissolve. Let us check example. again I am saying this data is not perfect. I am giving you example, and for that purpose. So this is 120 gram salt will dissolve at 30 degrees Celsius, suppose. Now add more salt, keep temperature constant at 30 degree. No more salt will dissolve. We can say water is saturated with respect to salt at 30 degrees Celsius. Okay, so what is the word we are using? What is the solute? Solute means here I am adding out salt. So salt is called as here solute. What is solvent? Solvent means in what substance I am adding out solute? That is water. So in this case water is considered as solvent. Sodium chloride or salt added, that is considered as solute, and on mixing of solute into solvent we are getting solution. Followed? All right. Not followed? Pause this video, revise and twice thrice listen. You will get. Now water is solvent. So I am explaining condition. The solution is saturated with respect to salt at definite temperature, that is 30 degrees Celsius here. Now again repeat the experiment. Heat water till 40 degrees Celsius. You will find more and more salt will dissolve in that. And suppose say again 140 gram it can be. So that salt is dissolved over here. Again add 10 gram salt more, but don't rise temperature. You will find that salt will be there at bottom. So again I am saying the solution is saturated with respect to salt at 40 degree, that is definite temperature. Getting idea? So this way on rising temperature more and more salt can dissolve. Why? Because intermolecular gaps are increased, and therefore more and more water can be more and more substance can be accommodated in that water molecule or in that gap. Now on heating, wait and allow to cool down solution slowly. Say from 40 degree it should come to 30 degree. As temperature start decreasing out here, that is from 40 to 30, the solution will have more salt already dissolved. We are saying this condition as super saturated solution. Saturated, you are aware. Now what word we are using? Super saturated solution. This is not bearable condition because water molecules are coming closer. Intermolecular gaps start decreasing out. So whatever extra salt is dissolved, say at 30 degree it should be 120 gram, but at 40 degree it is 140. So when temperature will fall from 40 to 30, whatever the excess salt is there, that is 20 gram. You will find that 20 gram salt is coming out from solution. This particular situation we are calling as precipitation. I am using word here precipitation. Try to understand the concept. Whatever extra salt is dissolved at higher temperature, only that will come out. Not entire salt will come out, but only 20 gram salt, that is extra, that will come out of solution. We are using this word as precipitation. If we carried out this perfectly, this is crystallization also. But right now I don't want to explain what is crystallization concept. In some other lecture we are going to definitely explain these all. Now from 140 to 120, 20 gram salt will come out. Again cool down from 30 to 20 degree. You will get whatever extra salt is there dissolved, that will come out. So what is the quantity of salt in solution? 100 gram. What is the precipitated salt? The extra 40 gram will precipitate out. You can check out by filtration and then check out the weight of dry salt. You will get around 40 gram. Some experimental errors are there, forget of that. Now here the solution is not entirely salt free. It is having still 100 gram salt in that because it is saturated at that temperature. Getting idea? Suppose I am cooling down to 10 degrees Celsius, may be possible still 20 gram salt can come out from solution like that. This process is called as precipitation. Now in order to get precipitation, certain things are required Usually we are calling that as nuclei. Don't confuse the word nuclei with nucleus in the atom. Nuclei means we are considering as center. That wrongly we are calling as nuclei. Some body should be there. On that, precipitation may occur. Say for example, just make glass rod scratch on the wall. Fine glass particles will come out. Immediately you will get precipitation on that. You may check out this also. When this type of supersaturated solution is there, at that time some substance, fine substance is required. On that, precipitation occur fastly. We can add out seeds also. Seed means don't consider seeds of plant. Say fewer crystals of sodium chloride we can add. That can serve as seed and precipitation occur around that. Even dust particle may work here. So like that, some particles are required. That is beginning of precipitation on that. So we are using that as seeding effect, nuclei or center. Like that words we are using as precipitation. Getting idea of precipitation? This is the concept of solution. We are using word here unsaturated, saturated, supersaturated. Unsaturated means suppose 20 degrees Celsius, 1 decimeter cube water can dissolve 100 gram, and suppose it is having only 50 gram. So it is salt solution, but unsaturated. We can still dissolve 50 gram salt in that. Then this word is used as unsaturated. What is saturated? At 20 degrees Celsius, suppose 100 gram is the capacity for 1 liter, then it will be 100 gram only. If you are adding out 1 more gram, it will remain as undissolved substance. So this is saturated solution. And what is saturated solution? Supersaturated solution, say at 40 degree we have 140 gram. Now temperature comes to 30 degree, but still 140 gram or 120 plus salt is there, yet precipitation is not occur. It is going to occur but not occur. This solution is called as supersaturated solution. So this word precipitation, temperature sensitiveness of precipitation, all these things we discuss here with respect to water as solvent.